Okay, we're going to graph a polynomial function. This is a third degree polynomial function, and that's because the greatest power of x that you see is 3. And when you're graphing a polynomial function without a calculator, I have 3 steps that I'd like you to follow. The first one is to find the x-intercept, or intercepts. These are sometimes called zeros. So the x-intercepts are the values of x where the f of x value or the y value is 0. I'll show that to you in a minute. Step 2, find the y-intercept. There's going to be 1 because this is a function. If it had more than one y-intercept, then it wouldn't be a function. And 3, we're going to use a table to plot other points on the graph. Okay, so let's start with step 1. We want to find the zeros, or the x-intercepts. And the first thing you should look for is if you can factor this. Can you factor the polynomial? And the answer is yes. This is a factorable polynomial. Okay? And I am going to look at it, and I'm going to use the first rule of factoring. Now, the first rule of factoring says that when you're factoring an expression, always factor out the greatest common factor first. Okay? And when I look at each of these 3 terms, 2x cubed minus x squared minus 3x, I see that they all have an x in common. So I'm going to write x, and then I'm going to put everything that's left in the parentheses. So now we have 2x squared. So we have 1 less x there because we factored it out. Minus x, okay, same thing there, minus 3. Okay, we don't have 3x, we just have a 3 because we factored the x out. Okay, now we're not done yet because this trinomial 2x squared minus x minus 3 can also be factored. So I'm going to continue to factor this. I'm going to leave the x out there, and this is a trinomial that can be factored. And you may have to make a couple of tries if you're doing this on your own, but I know that we'd have to have a 2x and an x in the first position of each parentheses. Okay, and then we would have a 3 and a 1 here, because 3 times 1 is 3. Those are the last terms, and they have to multiply by 3. But they also have to multiply to be negative 3. So one of these has to be plus, and one of these has to be minus. So it turns out that the factors like this. Okay, so we did it. We factored the polynomial 2x cubed minus x squared minus 3x. Okay, so now this makes it really easy to see what the zeros or the intercepts are. Okay, we have this right here, we have this factor right here, and this factor right here. Those are 3 factors. So the zeros, okay, I'm going to get the zeros by setting each factor equal to 0. And 2x minus 3 equals 0, and x plus 1 equals 0. Okay, now I'm going to solve for x. Now this is already solved for right here, so that means it has an x-intercept right at 0 on the x-axis. So I'm going to go over here to the graph. I'm going to put a dot there to indicate that the graph goes through that point. Okay? Now I'm going to go back over to this next factor, which I set equal to 0. When I solve, I add 3 to both sides, so I get 2x equals 3. And then when I divide by, both sides by 2, I get x is equal to 3 halves. Okay, that's 1.5. Okay. Now, I don't know if you can see the grid lines here, but 1.5 would be right about here, okay, right in the middle. So each of these squares in the background are 1 unit. So I'm going out 1.5 units to the right from the y-axis. Okay, and there's one other x-intercept. So I'll underline that, and then I'm going to subtract 1 from both sides to get x equals -1. Okay, and there is the other x-intercept. So my polynomial graph is going to pass through these 3 points, these 3 intercepts. Okay, and now the y-intercept in this case is also 0. If you were to, I'm going to write this out, y-intercept. The way you find the y-intercept is you always set x equals 0. Set x equal to 0. And then you just solve and you find out what y is. So you set x equals 0. So when you do that, the y-intercept is just 2 times 0 cubed, which is going to be 0, minus 0 squared, which is 0, minus 3 times 0, which is also 0. So the y-intercept is y equals 0, but in this particular graph, it coincides with the x-intercept. So the x-intercept and the y-intercept are both 0. Okay, so now let's get to the last part, the table. So before I join these 3 points with the graph, I'm going to make an xy table, and this is going to help me to find some other points on the graph, because 3 points just aren't enough for me. So I want to make an xy table, okay? And I'm going to pick some values of x that aren't x-intercepts. So the x-intercepts are 0, 3 halves, and -1. So I don't want to pick those because I already know that their values are 0. They're right on the x-axis. So I'm going to look at the graph and say, okay, what if x is 1? So I'm going to put 1 in the table right here. And I'm going to also figure out what if x is 2, okay? And what if x is -2? Okay, well, let's go ahead and work this out, okay? So if x is 1, then I'm going to substitute 1 into the polynomial. So it'd be 2 times 1 cubed, right? Minus 1 squared minus 3 times 1. Okay, so that's 1 cubed is 1. So 2 times 1 cubed is 1. It's going to be 1. And then 1 squared is 1. So it's going to be 1 minus 1, and then minus 3. So that comes out to be -3. It's probably hard to see my work right there. Sorry about that. Okay, so look at this. When x is 1, y is -3. So that's the point. See, we just found a point on the graph. It's the point 1, -3. So I am going to plot that point on the graph. So I'm going to go out 1 and then down -3. It's right down here on the graph in the 4th quadrant. Okay, so I'm coming up with more and more clues about what the graph is going to look like. Okay, now what about when x equals 2? Well, this is going to be 2 times 2 cubed minus 2 squared minus 3 times 2. Okay, so I've run out of room a little bit here, so I'm going to do some of this work in my head. So 2 times 2 cubed, now 2 cubed is 8. And then 2 times 8 is 16. So I'm going to try to fit a little 16 right in here. Okay? And then minus 2 squared, well, that's just minus 4. Okay, so I'm going to put minus 4. Okay? And then minus 6. Oops, minus 6. Make sure that's visible. Okay, so we have 16 minus 4 minus 6. Well, 16 minus 4 is 12, and 12 minus 6 is 6. So we have another point on the graph, okay? That's point 26. So I'm going to I'll put it right here, 2, 6. So I'm going to put that on the graph. So that's 2, and that's going to be way up here in the first quadrant. That's the point 2, 6, okay? You can go ahead and count if you want. It's 2 units to the right from the y-axis, and then 6 units all the way up. Okay, so the last point we're going to check is -2. And it's going to be very similar to the one above, but we have to be careful because we have a negative. So I'm going to put 2 times, and I'm going to put the -2 in parentheses because I'm dealing with a negative raised to a power, and I want to use parentheses and be really careful, minus -2 squared minus 3 times -2. Okay, well, what does that equal? Well, let's continue right below. So that's 2 times, now -2 cubed, that's -2 times -2 times -2, which is -8. -8. There we go. Minus, and then we have -2 squared, which is 4. And then here we have minus, now 3 times -2 is -6. Okay, so now we're going to simplify a little bit more. So this is 2 times -8 is -16 minus 4. Now, subtracting a negative is the same thing as adding a positive. So it's going to be like this. It'll be +6. Okay, so now let's simplify this. When you have -16, you take away 4, that's -20. But when you add 6, you're going back up again, so that's -14. So this equals -14. So now we have another point, -2, -14. Now that point is not really going to fit on my graph, but it's all the way down here. I'm going to put a little star down here because that's where that point is. So now we're going to draw the graph. And we have to remember that polynomial graphs, they usually have some kind of S shape, but they're defined everywhere. Okay, there won't be any gaps or stopping points. Or it might look like this. There's all different ways polynomial graphs can look like. So when you graph it, you have to think, okay, I'm going to join the points. They're going to go through the x-axis only at those points. They're not going to cross the x-axis anymore. So I know that the graph has to go through like this in order to come down and pass through this point right here. And that's, and I'll just stop there because we're going to slowly connect the points. Now I know that the graph also has to go all the way up here. So my graph isn't going to be the neatest graph in the world, but the graph is going to look like this. Okay? Okay, that's going to have to do. Okay, and then the graph is going to come back up at some point. It may or may not be at the point 1, -3. It might be a little bit lower, but we're just drawing a general graph here. And it's going to come up to the origin like this. So it has to, because the graph has to come up and cross the x-axis. Now something's going to happen in between the 0 on the x-axis and the point -1 on the x-axis. And it somehow has to come up and then come back down again. That's the only thing it can do. It has to come back and go through that point. And remember, it doesn't go through any other points, just those three on the x-axis. And then I'm going to continue straight down. Okay, I put that star there because remember that point is the point -2, -14, and I can't fit that on my graph. So there you go. So there's the graph. It's not the neatest graph in the world because I'm learning to use this writing tool, but that is the graph. That's it.